This movie will demonstrate the possibilities of VisMeB, the Visual Metadata-Browser. It is developed by the Human-Computer Interaction faculty of the University of Konstanz in Germany. Based on an extensive user study with 40 users, different visualization and filter techniques were joined into one single system, the supertable. To further ease the information finding process, a scatter plot was added. All visualizations that are used in VisMeB, like for example bar charts, circle segments, or tile bars, are well accepted and known to enhance the human visual capabilities. VisMeB combines these and other generic visualizations to effectively support the visual information retrieval process. VisMeB consists of different components. The core is a supertable scatterplot-based visualization. To formulate a query, either a query form or a query preview can be used. The query preview follows the concept of a circle segment view and helps to avoid 0 or million hit queries. As an alternative to the scatter plot, it can also be used as a visual filter at a later point in the retrieval process. VisMeB can connect to a variety of database systems like Oracle, Postgres, or MySQL. Currently, VisMeB can search on a movie database, a geospatial database, and a database with crawled web documents. To visualize the different structured contents of the databases, a configuration and assignment tool was implemented. With this tool, users can assign metadata to their visualizations of choice. This is George. After a long day of work with his colleagues, he and his friends decided to meet in the evening and watch a movie together. George has to pick a movie that suits everybody. He starts VisMeB and connects to the movie database. With a simple query form, he starts a search for an adequate movie. Let's say that the movie for the evening should be a recent science fiction movie with some action and also dramatic moments. The result set is displayed in the supertable scatterplot combination. The supertable itself has two design variants. The one displayed here is called the level table. George can change the level of detail that he wants to see. The amount of information increases with every level. Each metadata have their own column, but not all metadata are visible in all of the 4 existing levels. Level 1 provides an overview of the documents. Only numerical values, like for example relevance or size, are displayed in bars. Each search term is mapped in a different color. The single relevancies are displayed as bars. Moving the mouse over a row shifts this row to the next level, but leaves all other rows in the first level. This fisheye technique is very convenient to quickly check a single document set. George has found some interesting results. He needs more detailed information about the movies, so he goes to level 2. To change a level, he just clicks on the level buttons in the upper left corner. We can see that the whole body of documents has changed to level 2. More information is displayed. The relevancies of the single keywords are now numbered and allow an easy comparison. Level 3 has an additional, very useful feature. VisMeB divides the document text into artificial text segments. The segments are visualized in the relevance curve. Query relevant information in the segments is marked by vertical bars. Their height illustrates the relevance, while the length of the visualization reflects the document's length. This idea is even stronger focused in level 4. In level 4, the scatter plot has now changed to a browser view. If we move the mouse over a row, the underlying document text is displayed in the browser view. Additionally, the detailed relevance curve can be used to navigate to interesting parts of the document. Segments containing one or more keywords are colored in the corresponding color. Moving the mouse over the detailed relevance curve darkens the corresponding text segment in the document text. Keywords are highlighted and easy to find. This brushing and linking technique makes it very easy to navigate through long texts. At first sight, this visualization might seem cognitively demanding and difficult to understand. It is interesting to note that in user tests, most users did not have much difficulties to work with it. Let us stay in this level a little longer. Now, George has narrowed down his search to 4 interesting movies. To read the plot summary of them, he can add them to the so-called browser view. This gives the opportunity to compare multiple document texts with each other. Now, what George doesn't know is that at the same time his girlfriend Lucy is looking for a movie as well. She wants to watch a funny movie in English which shouldn't be too old. But other than George, Lucy also prefers to search with the second design variant of the supertable. It is called the granularity table. Granularity is a term derived from photography and used for pictorial presentations on film. The higher the granularity, the more information is contained in the picture. We adopted this terminology to the visualizations. With the slider located in the most right column, the granularity of each row can be manipulated. The higher the granularity, the more information is displayed. For practical reasons, this prototype has only 6 levels of granularity. After submitting the query terms, Lucy can see the whole data set at a glance, but only the global relevance bars are displayed. Level 1 contains the same fisheye technique as in the level table.